My name is Charles Other. Welcome to my Physics 2 Lab 1 Charge Tapes Lab. The overall purpose of this lab was to find the excess charge on one piece of clear tape. This charge was created by ripping pieces of tape off each other and just seeing the overall result. An equation we have to know is Coulomb's law, which is the electric force is equal to K constant times Q1 times Q2, which in this case is just Q squared for the experiment, times the R hat, or the unit vector of R, divided by R squared. We have to know about electric fields to dictate um, the overall charges of the piece of tape. Within the force due to gravity, which is force equals negative mg, which is mass times gravity. And then the K constant is 9 times 10 to the negative 9. And the charge of the electron is negative 1.6 times 10 to the negative 19. When deciding the overall charges of the tape, we were given a pin which has a set negative charge. And when the pin interacted with the piece of tape, we found that the tape started being attracted to the pin, and then we know that the tape has a positive charge, and then when we had our hand next to the piece of tape, the tape also went to our hand, which also tells us that our hand has a negative charge. So the overall setup and measurements for the main lab was a piece of tape which was zero point 0.2 meters in length, the mass of tape which was 0.2 grams, and when we brought tape A to tape B, it had a total displacement of 0.004 meters. More results we had was the magnitude of charge we found for the charge of the electron was 1.867 times 10 to the negative 9. We had the magnitude of gravitational force and electric force being 1.96 times 10 to the negative 3, and they're equal to one another. The amount of electrons we found was dividing the charge of Q, the charge of Q by the charge of an electron, which gives us 1.167 times 10 to the 10 power. The amount of electrons we had, or amount of atoms we had, sorry, was 3.8 times 10 to the 17 atoms. Like I said before, the gravity and electric are equal to each other. So when finding Q, we'll have mg equals k times q squared divided by r squared. That ends up us getting 1.867 times 10 to the negative 9, like I said before. Here's the overall code. We have our initial measurements from 5 through 9, which is just the K constant, gravitational constant, tape length, tape mass, and the displacement of the tape. And 11 and 12, we also have the force of gravity and the forces of the electric, which we can just make it more simple by just doing mass times gravity for both, except the G is just negative. For Q114, we just have exactly what we did before, the square root of mass of mg times the displacement of the tape squared divided by k, and then we're printing out the overall charge 15. And 17 through 15 is just 17 to 25. Sorry, is just showing off, like right here, it's just showing us how the tape would look in general with all the forces acting upon it. And we know that the magnitude, like we said before, is 1.867 times 10 to the negative 9. Some assumptions we have to make when doing this lab: we have to ignore air resistance on a moving object. We have to treat the long tape as though it were a point charge, with all the charge concentrated at the center of the long tape. We also have to assume that each U tape we made had about the same amount of charge, evenly distributed along the length of the tape. Instead of what ifs and why, what if electrons had positive charges and protons had negative charges? What would change about the observations you made with the tapes and other charged objects? The charges switched, then the pin would be attracted to the tape because positive charges get attracted to negative charge, but the overall result will be the same, just inverse. And why is it important to handle the charge tapes as little as possible? What happens when the charge tapes come in contact with your hands or other objects? The answer is, if we wait longer to interact with the tape, my hand or other object would take some of the charge from the tape and cause it to be less powerful or have less overall charge. Thank you.